So the only thing I'd offer to you guys is, again, just to kind of like make sense of this. We don't know the value of k. But we do know the absolute value of x plus 3. 1, 2, 3. Right? That's the V-shaped graph. Looks something like that. X is less than 0, so it's only there. Right? And then we have the quadratic here, which is only x is greater than 0. So that's going to be from there. So what basically all they're asking us to do, sorry, that's an open circle, is what operation do I need to add to x squared that's going to make these connected? And remember, if we're adding something outside the function, that's shifting it up or down, right? So you just look at this and say, all right, well, yeah, if you just add 3, that shifts that graph up 3, right? So the value of k that makes this continuous is k equals 3. Now, let's look at this from the algebraic perspective, because this was an easy one graphically, right? If you just like graphed it, you can see, oh, OK. So again, what value are they discontinuous at, or originally started at? 0, right? But our goal is to make them equal to one another. Yes? We want the y values to be equal for the given x value. So basically, if we want things to be equal to each other, if we want the y, remember guys, these are y equals, or let's write it like this. This is y equals absolute value of x plus 3, and y equals x squared plus k, right? So if we want the y values to be equal to each other, that means we just need to set these equations equal. So we'd say absolute value of x plus 3, it has to be equal to x squared plus k. We want the y values. These both are replaceable for y. We want y to equal y. We want the y coordinate to be the same as the other y coordinate. But when? We want them to be equal when x equals 0. So now you just replace 0 here. And this algebraically is relatively easy to go ahead and solve. K is equal to 3. So I want to show you guys the algebraic method, because if you guys try to replicate what